This is the EPA Tools and Resources webinar series. And today we're going to be focusing on an EPA Region 4 and Office of Research and Development urban background study. The study involves the collection of data on urban background concentrations of metals and PAHs. The background data can be used to inform decision-making in urban settings in the southeastern U.S. and also methods that can be used elsewhere. If you have a related science question during the presentation, we ask that you please type it into the chat pod on the webinar screen. And once the presentation ends, we will answer as many questions through the chat pod as the time allows. And you can listen through your computer speakers or through the phone audio line. Once we start the presentation, we're going to mute all the lines to cut down on background noise. So I'm pleased to introduce our presenters today from Region 4. The folks walking us through the slides will be two risk assessors from Region 4, Tim Frederick and Sydney Chan. At this point, I'm going to turn it over to Felicia Barnett. Felicia is the Director of ORD's Site Characterization and Monitoring Technical Support Center located in Atlanta. We're all calling in from different locations today due to winter weather, but hopefully things will go smoothly. So Felicia?
And I'm muting lines now. Thank you.
The leader has muted your line. To unmute your line, press #6.
All right. Hello. Good afternoon, everybody. I'm Felicia Barnett. Can everybody hear me?
Yes, we can.
Yeah. Okay. Excellent. I am EPA's Office of Research and Development, the Superfund and Technology Liaison in Region 4, and I'm also the Director of the Site Characterization and Monitoring Technical Support Center. I've been one of the number of Office of Research and Development collaborators on this project with Region 4, and we welcome you to this webinar. Soil in long-established cities has accumulated decades of low levels of pollutants caused by urban activity. Deposition of metals like lead and arsenic and other chemicals like polynuclear aromatic hydrocarbons or PHs come from historical industry activity and manufacturing materials used to build the infrastructure of modern society, which adds to natural levels of metals in the soils. This widely dispersed levels of chemical concentrations are known as urban background. Understanding these levels of urban or naturally occurring substances in an area is one of the necessary components for investigating the possible release of hazardous substances from a site which have related chemicals. In 2015, EPA scientists partnered with several Region 4 states as part of a regional applied research effort, RARE project, to determine how urban background contaminants differ from industrial waste at urban sites. Efforts are focused on creating a process for both soil sample collection and analysis that could be consistently applied and developing a database of urban background concentrations across southeastern cities. To present this study, I am pleased to introduce Tim Frederick and Sydney Chan, who are Human Health Risk Assessors in the Superfund Division of Region 4 in Atlanta. They provide technical support in the areas of human health risk assessment, toxicology, sampling, and statistics to EPA project managers on a wide variety of sites in the Southeast and are two of the lead region contacts for this project. Tim has worked in the region's Superfund Division since 2005 and serves on several national work groups. He also teaches graduate courses at Emory University and Georgia State University of Public Health. He earned his bachelor's degree at the University of Miami and a master's of public health from Emory University. He is currently acting as the chief of the scientific support section in Region 4 in the Region 4 Superfund Division. Sydney has been working with EPA since May 2016. She's been working at the agency. She earned her bachelor's degree at the University of South Carolina and a master's of public health at Georgia State University. She began working on this RARE project during her internship in 2015, and she's been part of the team that was awarded the 2017 Superfund Team of the Year award done at the former Chattanooga Foundry site, which is going to be part of this case study. So Tim, I'm going to turn it over to you.
Thanks, Felicia. Okay, so we're going to talk about the urban background study that we've been conducting in Region 4 for a number of years, as Felicia indicated. And background is something that if you've worked in the site investigation arena, sooner or later you've wrestled with trying to define what background is at a given site. We collect background in the Superfund program for a variety of reasons, but usually what we're trying to get at is understanding whether the contaminants that we're seeing at a site are related to a release from the site that we're looking at, or if it's part of a larger area-wide background contamination that's naturally occurring or from human activities that are unrelated to our site. So we usually, when we're thinking about background, it's typically broken up into two kinds of ideas of background. We have what's naturally occurring, the things that would be in the environment if humans never existed or impacted the environment very lightly. And then we have anthropogenic levels. Anthropogenic levels are things that are there because humans have been interacting in the environment for some time and kind of moving things around. We usually think of this as things that are present from non-site sources, driving around, combustion in vehicles or chimneys, or lead-based gasoline is a great example of how contaminants end up in the environment that aren't coming from site sources but are present in our urban environment from humans living in it. Our problem with understanding that anthropogenic side of things is that we really haven't, to this point, developed a robust data set of what those concentrations look like. I get documents all the time in the region that say, well, these PAHs are background because it's near a road, and everybody knows that this is typical. And so the question always comes up, well, is it typical? Is this what we would expect to see in an urban setting? Or is this from a release from the site? So trying to understand what that anthropogenic urban background situation looks like is a major challenge for investigators in urban settings. We do have national background data. The USGS put together an amazing document. Their data series 801 undertook to collect thousands of samples across the country to understand what background contaminant concentrations, specifically elemental contaminants, looked like in soil. However, that data set, as amazing as it is, specifically excluded urban areas. So we have a good snapshot of what naturally occurring background looks like, but we don't really have a look from that document on what background looks like, anthropogenic background looks like. So, this map looks at my Region 8 states, Region 4 states. We have 8 states in Region 4. And when we plot the samples across our region for lead, this is what it looks like. So we have a nice wide, kind of spatially wide sampling program that was implemented that gives us a nice broad look across the region. But the data gap here is, kind of what happens in the more densely populated, kind of, finer focus in specific cities or urban areas. So that's in a nutshell what we were interested in learning through our study. Another piece of the urban soil problem is that urban soil is different. Usually when we're looking at a site, we try to take background samples that are from the same soil types, in some unimpacted area nearby that has similar geology as our site. Urban soil is different. When we look at this USDA soil survey map, the area in white is simply defined as urban land. There is no understanding of what that looks like on a native basis because it hasn't been native in a few hundred years. when we look around these other areas, these are soil types, but these are identified as a native soil hyphen urban land complex. So even native soils have been impacted by urban development. So trying to understand what our soils look like in an urban area can be complicated by just the things that have gone on in that urban space. So when we began to look at what we can do about this, the idea originated with staff at the Kentucky Department of Environmental Protection. They came to us after a project that we worked on where we had some disagreements about background, frankly, where we would have benefited from having a robust urban background data set. It was a fairly typical investigation of an urban setting. We had maybe 6 or 10 background samples, no more than that, where we were trying to draw broad conclusions about what background was. So after the dust settled, we were talking about what an urban background study might look like, and is that something that we could undertake in partnership? And so with that seed planted, we began to look around for where we might get some funding to do that. EPA's Office of Research and Development offers regional applied research effort grants, or RARE grants, to the regions to kind of do studies like this. So we decided to partner with all 8 Region 4 states, various labs and offices within the Office of Research and Development, our lab in Athens, Georgia, that supports Region 4, as well as the Superfund and RCRA division. So we kind of got a big group together to partner to develop this urban background study and see what we could do. So we set out with we were awarded the grant, but we had 2 main project goals identified in our grant application. One was to develop a robust, fine-scale regional data set that would be representative of anthropogenic urban background concentrations in the cities that we sampled. So we would go to as many cities as we could and collect a robust data set and see if we can start getting a handle on what urban background looks like. What does it mean? The other thing that we wanted to do is while we were setting out to collect this information, we thought that it would be a good selling point and it would be a benefit to others who wanted to do this if we came up with methods that we could share, that we could hand off to other people that wanted to do this, so we can make all of the data that would be collected under this or similar programs as comparable as possible, so that we could share data across regions and kind of understand what the data meant. So a data set of urban background as well as tools that we can hand off to others. So when we got this large group together, we began with a series of calls to talk about what do we want to accomplish, what is it going to look like when we go to the field. And this was a laborious process. We had 8 states, several offices of ORD, different divisions in Region 4, trying to arrive at a common understanding of what an urban background study might mean. We knew that we wanted to be replicable, and when we went to City A, we wanted it to look like the same sampling that we did in City B. We wanted C to follow the same procedures so that we could compare the data. We knew that we wanted to do as many cities as we could. When we selected cities, we left that to the nomination of the states. Tell us what cities within your states we should go to. We didn't tell the states where we were going to go. We kind of, we're trying to work in partnership here, but also provide the states with some useful tools, but things that were going to be useful to them directly when we were done. Early on, we decided that that we wanted to focus on metals, and specifically we looked at the RCRA 8 metals, and we wanted to look at PAHs, polycyclic aromatic hydrocarbons, as common pollutants that we as regulators wrestle with in urban settings all the time. In a perfect world with unlimited funds, we probably would have looked at dioxins and pesticides as well, but we don't live in that world. So limitations to funding, time, et cetera, limited it to that scope. We know that we want to make this data available in a publicly available database, kind of like that USGS Series 801 data. You can go to the website and download a spreadsheet and do whatever you want with it. That's our end goal as well, where we want to get with this. And again, we wanted to have that sampling analysis plan / quality assurance project plan, or SAP QAP, that we could hand off to others as well. So through these discussions, we came up with a sampling plan that looks like this. We would lay a grid, and we were trying to make this as non-biased and as science-y as we could. So we began by laying a grid across a city. And over time of negotiation and seeing what worked and what didn't, we settled on a 7 by 7 mile grid in Region 4 cities that seemed to be the size that fit over the urban areas of most of our cities. I don't know what's happening to my thing here. Here we go. Sorry, it's jumping around here, and I don't know why. Okay. Back to this. So we laid out a 7 mile by 7 mile grid, and that's what we're looking at here. Within that grid, the individual cells are a ½ mile by ½ mile, which yields a total of 196 possible cells that we could sample within. To not bias this in any way and to be as representative as possible, we decided that we would randomly select the grids that we would sample within. So we were going back and forth on what those numbers should look like. We wanted a robust data set. We started out talking, or I started off with the goal of collecting 100 samples, and again, budget and the realities of field time and those other things kind of constrained us a little bit, but we eventually settled on 50 samples. So we're collecting 50 randomly selected samples within a grid. If a grid turned out to be unworkable for some reason, that, like, you know, if a sample ended up at the airport, for example, in the city, that would not be representative of the larger urban area, so we would take that one out and replace it with randomly selected sample location 51, for example. The final determination ultimately is made in the field on where exactly the sample comes from, but this is the general idea. This is how we set up each of our samples.
And Tim, I might ask you to make sure that your presenter view is following along on the correct slide number.
Okay. I don't know where we are. Let's see. We are. So we should be on slide 9. Is that what everyone is seeing?
My view is slightly different on slide 2. I would just ask that you make sure that you are sharing at the top of your right-hand side of the screen.
Yeah, I'm seeing slide 9.
Okay. All right. Thank you.
I don't know.
I'm also on slide 9. You might just be frozen.
All right. Thank you all for your help.
But I do appear to have lost my controls to move to slide 10. I have dropped off here somehow. Oh, here I am.
Yes, you've been lost as the host, Tim. Sydney,
Yeah.
can you move the slides? Tim, can you just say next slide?
Sure. Next slide, Sydney. Okay, so sorry for the mishaps. Again, being in different locations because of the snow is impacting us here in the south, something that we're not used to. So once we had a sample cell determined, we would begin in the middle of that cell and start looking for where, again, it's a ½ mile by ½ mile. So we're looking at a nice chunk of land. Where are we going to take our sample within there? So we had some things that would qualify or disqualify where we took our actual samples. Our first criteria was going to be areas that appeared to be representative of the larger urban setting. That's very subjective, but you kind of know what that looks like in the field. Is this typical of the city? Again, the airport probably isn't representative of the larger city, so we might move out of that spot. We wanted to look at soils that had been around a while, that would have been impacted by cars driving around, from combustion, what have you, from urban activity. So we wanted to look, we didn't want to go to recently developed areas, and we would look at old aerial photographs to see, has this area changed, within this grid. And probably most importantly, we wanted to sample from publicly owned areas, such as rights of way and within government-owned property. The reason for this was one of getting EPA. We need to get signed access agreements when we go somewhere to collect samples. It's a legal requirement that we have within the region. So rather than asking 50 private landowners to sign a form and go through our song and dance, if we could get a signed access agreement from the city of X, from the Department of Transportation, from the Parks and Rec Department, et cetera, that would greatly reduce the level of effort needed to get those signed access agreements. So under our disqualify realm, we would look at things like private and residential yards. So we wouldn't sample within a private landowner's yard. We would sample in residential areas for sure, but we were limiting private ownership for that access. We would avoid industrial properties to avoid potential point sources that might bias our numbers high. Again, we would disqualify areas that had recent development, and we would also disqualify low-lying areas where surface runoff might be coming from parking lots and stuff all over into one central area. So that was our general criteria for disqualifying an area. Teamwork was critical to this entire process. Working with our states in the field was critical. Most states supported us by going out and looking at sample locations ahead of time and determining, yes, that sample location looks good. They also helped us by providing field sampling staff. So with our research dollars from our grant, we were able to leverage our money, rather than paying contractors or as many contractor staff, if we had state personnel out in the field sampling with EPA staff, we could really stretch our dollars out a lot. And we really, were able to leverage our money within an inch of its life here. It was really critical having states out there with us. Can't understate that enough. So in the field, this is a technique that we settled on to make sure our samples were reproducible and would continue to be representative from site to site, collected in the same way. We were looking at the top 2 inches of soil, and we chose 2 inches because that's what USGS did in the nationwide study to look at their first sample. They went deeper than that as well, but we were interested in surface soil and near surface soil as the area that's going to be where aerial deposition or other deposition is going to occur in our conceptual site model. So let's look at that top 2 inches. We used a turf profiler for a couple of reasons. One is we could get a nice look at what our soil samples look like. But again, it's standardization. We could stomp our turf profiler into the ground, pull it out. We've got a plug of dirt. We would take off the organic layer at the top. We would measure down 2 inches and then discard anything below that, and that was our sample. And we could do this at each sampling location. Something else that we did in the field was we did our sub-sampling in the field. I don't know why it keeps jumping ahead too, but sorry, bear with us. So we were doing sub-sampling in the field, and the purpose for this is that we were sending off 2 jars for analysis, right? We were sending off a metals and a PAHs. We wanted to do something a little more rigorous than the stainless steel bowl and the stainless steel spoon, stir it around and kind of divvy it up. So what we did in the field is we took a shipping container box, some aluminum foil, and did a 2-dimensional slab cake. We used a subsampling tool where we would kind of go incrementally through our sample and build the subsamples into the 2 jars. And we did this at every place, again, to be as rigorous as we could be and not biasing particle sizes one way or the other as we move through the field. So that's how we were collecting our samples. The other thing that we were doing was using tablets in the field to collect metadata. So every place that we went, we had a person in the field with a tablet that was collecting photographs and other information about that sample location. We used Esri Collector to help us geolocate all of that. We used iForms to collect standardized material. So in this way, no matter who was sampling, where we were sampling, we were collecting the same kinds of data, and it was more efficient than having many different people's field logbooks that we would then have to compile into something on the back end. So in real time, we're collecting metadata at each sample location. Here's what that looked like. So the form on the left, we're collecting, what city are we in, what sample grid, information about whether, what's nearby, is there a major roadway, we're getting the lat longs, et cetera. We also collected a standard battery of photographs. So the pictures numbered 1 through 6, or we took typically at each sample location. So 1 and 2 were 180 panoramas from our sample location. 3 was a picture of what our soil profile looked like. So we pull out our turf profiler, take a picture of what that dirt looked like. 4 is where the sample came from. 5, after we disaggregated our sample and before we did our subsampling, we'd take a picture of what it looked like to see what kind of soil it is. And then number 6 would be some landmark in addition to the lat long that would help us find this sample site location again in the future. So this kind of just shows when we're done, kind of like the relative sampling density. This is the state of Kentucky, and in white circles is where the samples that the USGS collected across the state, so very wide scale. The red are the city of Louisville. We have 50 samples in a very dense area. So we're kind of looking at a similar kind of sampling, but on different scales. One is a undisturbed wide scale, and the other is kind of that man-impacted, very tight scale. So I'd like to share with you some preliminary results. When we would get back to the lab, when we get our data back, we would just do some very general statistical analysis. EPA has a software that does this for us called ProUCL. Those of you who've worked in risk assessments will be familiar with this. You can see it's got min, max, means. We have various percentiles. And all of that's useful for looking at, if we were interested in understanding the mean for a city, we can look at that and compare those. If we're interested in looking at the variability, we could compare the standard deviations or the coefficient of variation down there at the end to understand how variable the data is, et cetera. Another thing that I like to do with data is look at it graphically. ProUCL makes box and whisker plots. And so this is an example of a box and whisker plot that I did for lead. So the statistical analysis I just showed you was all for lead. This is this is our results for the 7 cities that we've sampled so far for lead. A couple of things to point out. If you're not familiar with the box and whisker plot, how these are built is the bottom of the box is the 25th percentile. The middle here is the median, and the top is the 75th percentile. The distance between the top and the bottom is called the interquartile range. And this top whisker is 1.5 times, measures 1.5 times that interquartile range. Samples that are beyond that interquartile range are potential outliers. What's nice about this is graphically we can look at our 7 cities and just kind of compare them just by looking at them. I've also included here this black line is the regional screening level of 400 milligrams per kilogram for lead. Regional screening levels are developed by EPA to kind of look at de minimis risk levels where if we're below this, we don't anticipate health effects. If it's above that level, we may need to carry it forward in the risk assessment or do something else. to evaluate that further. So it's kind of a minimum level where if we're below it, we probably won't see health risks, and above that, we need to do some additional work. So what's interesting here is our medians here, the pinch part in the middle, are all kind of well below 400, which is good, right? But we do have occasional potential outliers that are above that. Looking at another thing that we can do with box and whisker plots is we have that USGS data. We can compare what our urban data looks like directly to the USGS. And again, I didn't note this earlier, but I think it did. The USGS is looking specifically at elemental compounds, metals. They did not look at PAHs. So, but for metals, we can compare the metals directly to the USGS data. So here we can see that although we're below that 400 milligrams per kilogram of lead, for the most part, in our Lexington and Louisville samples, our urban lead concentrations, just by sight, are higher than what we would see, and more variable. Those boxes are bigger than what we're seeing in the USGS data. So this tells us that our urban background data for lead is different than the natural background levels for lead. That was good to know. PAHs tell a similar story. PAH data was difficult. We had a lot of non-detects. Here I have my black line at the bottom, which is the EPA RSL, which is 115 micrograms per kilogram. The red line is the maximum non-detect that was identified. So that's, I guess, less important for us, but we had more non-detect data for the PAHs. But what's interesting here is that the medians for all of our cities, except for Gainesville, Florida, are above that de minimis risk level, that regional screening level of 115. So in urban settings, we have some level of risk that exists just from general urban contributions, man-made contributions to the environmental setting. And that was an interesting finding for us to look at. So our project status is that we've sampled 7 cities to date, and they're listed there. Chattanooga was not technically part of the urban background study, but we used the methods to sample it, and Sydney is going to talk about the case study there in just a moment. We plan on going out to collect 2 more cities, Atlanta and Columbia, South Carolina. All of our data is undergone laboratory QA/QC. So we're working with the states now to come up with what our format is and where it's going to be housed on the internet, where you can go and download it and do what you like with our urban data. That's coming soon, not yet. Today, there's a link here. You can go and download our SAP and QAP now and use and modify if it's useful to you, if you've got an urban setting like this that you would like to go investigate. When we're done with everything, our goal is to publish all of this in a peer-reviewed journal where we will do some additional analysis and arrive at some conclusions. That's down the road. Our impact, how we might use this data and how we have, we're filling the data gap of trying to understand the distribution of anthropogenic contaminant concentrations at an urban scale. I think this is a step in that direction. There's probably more work to be done there. We have used this several times to figure out if a background data set in a different city is does this look like what we're seeing in our other cities, or is it different somehow? And we can make those kinds of comparisons. We have robust data sets that are ready for HRS scoring, for remedial investigations, for site investigations, any number of uses near or in these cities that we've sampled. Something that occurred to me after the hurricanes this past year was that this data might serve down the road as a nice snapshot in time of what the concentrations are, where if we wanted to understand what the environmental impacts were of widespread flooding or other, kind of widespread disturbance of urban areas, we can go back to this data and, collect with new data, kind of see how things compare. So with that, that wraps up our kind of overview of the urban background study. I'm going to hand it off to Sydney Chan who's going to kind of walk us through where we use this urban background study method as part of a larger site investigation using the tools that we developed in the larger study. So take it away, Cindy.
Thank you, Tim. As he said, I'm just going to quickly go through a case study that we're calling former Chattanooga foundries. And the problem here was that historically throughout Chattanooga, there's been over 60 foundries, and they each generated some spent sand and baghouse dust, and we believed that this waste material was then used as fill in residential yards. We worked with the Tennessee Department of Environmental Conservation, the Department of Health, and the City of Chattanooga. When we were looking at Chattanooga, we thought, why should we use the urban background study? And we wanted to determine whether or not lead was citywide or it was specific to the area of where foundries could have used their waste as fill. As Tim had mentioned, the SAP plat developed for the urban background study is easily adaptable to fit whichever city you want to use it within. We ended up using the same field team that was used to collect all of the study's data before because they were familiar with the process from sampling the other 6 cities. And we also wanted to use the urban background study to further inform the site assessment to get a background, and any work later on within the site, it could help guide the remedial investigation. This picture is kind of showing this black sandy material up on top, and that's our foundry waste material, not native to the soils of what's below the brown. So how did we apply the urban background SAP plat to Chattanooga? So we needed a couple adaptations. As you can see, it's topographically we had to rotate the grid a little bit to fit between the ridges to cover the city of Chattanooga. And we also shrunk the size of the grid. As Tim had previously mentioned, it was developed as a 7 by 7 mile grid to fit the cities, but Chattanooga is a little bit smaller, so we shrunk it down to a 5 by 5. Same process of the random number generator, just like 50 randomly selected cells, and you can see all these little dots are the cells that the generator had come up with, and same qualifications and disqualifications of areas where we could sample. We wanted to exclude floodplain areas, areas within Chattanooga that we had known contamination, and also areas where we knew there were previous industries, previous boundaries. The sample time for the urban background took just 2 days in September, which was wonderful. And by the time all the data was compiled and analyzed and we got our results back, we completed and wrapped up the urban background section of the project in 2017. And once again, we got a box and whiskers plot. This black line going across the top is our regional screening level of 400 milligrams per kilogram, and Chattanooga is well below that with a median concentration below 60. We also looked at benzoate-pyrene, and along with the other cities that had been sampled in the urban background study, that black line is showing the regional screening level at 115 with our median slightly above that, showing that anthropogenically benzoate-pyrene is found above our regional screening level. So what did the urban background study application within Chattanooga show us? It revealed that there's not elevated lead everywhere in Chattanooga. Most of the background samples were below our regional screening level, as the box and whiskers plot showed before, and it's about the same as what we were finding in the other cities. Benzoate-pyrene is above the new regional screening level that the black line had shown, but it's within our risk range, so it's okay. We also, as Tim had mentioned, sampled the RCRA 8 metals. So arsenic was also considered at this site, and it was below, the background concentrations were below our levels of concern, so that was good. And now, after doing the entire background set, we have robust data to go forward for the remedial investigation.
Okay, so that kind of was a quick hit at the Chattanooga urban background case study that we did to support a Superfund site investigation. So to kind of wrap things up and then open up for questions, we just want to leave some take-home points for you to consider. The study that we've begun, we think, begins to fill an important gap for understanding what that anthropogenic background in cities looks like. At least on a regional level, we're beginning to, I think, get our hands around what that might look like. We're finding that anthropogenic background is different from that natural background, at least for some contaminants like lead, for example. We've demonstrated that we can take our SAP and CLAP and apply them to site-specific needs. And that was relatively easy, and it was great having that on the shelf. We saved quite a bit of money of being able to just pull that off the shelf, adapt it to our site-specific needs in Chattanooga, and go for it. And again, if you're going to undertake this level, this kind of study on a city level, teamwork is going to be critical to your success. If you don't have buy-in with your external stakeholders, cities, states, communities, it's going to be difficult to go forward. I've lost the slides again. But that was the end of our thing. We just also wanted to wrap up with some acknowledgments. All 8 of our states were instrumental in making this happen. Our national ORD